But the thing about logarithms is it's just really, when you finally break it all down, it's just a different way to write numbers. So it's a type of notation. So you guys remember when you learned scientific notation in pre-algebra or algebra 1? It's just taking a way to write a really long number and write it in a way that's a little bit smaller. That's pretty much what logarithms are. But it's a notation for writing exponential numbers. So that's kind of what we're going to be working with for 8A, is exponents and exponential functions and exponential expressions. So what we're going to do in the first example is first just kind of recall and go over again our rules of exponents. So if I have 5 to the 4th, first of all, what is the 5 called? Does anybody remember? That's the base, and the 4 is the exponent. So if I have 5 to the 4th, what does that mean? 5 times 5 times 5 times 5. So what does that give me? 625. Good. Okay, so 5 to the 4th is 625. What if I have a negative exponent? What happens there? You take the reciprocal, right? So we would move that 3 to the denominator. And what happens when I move it to the denominator? It becomes positive. So it becomes 1 over 3 squared, which is 1 over 9. Okay. Now what about anything with a power of 0? What is 9 to the 0? It's 1. Okay? The exponent 0 means that we're not multiplying the number at all. So that means that we're starting with the multiplicative inverse, which is 1. So we start at 1. So I wrote a note to myself on my notes, anything with a 0 power equals 1, always. Okay, so anytime something is raised to the 0 power, it's always 1 no matter what. Okay, what about 1 to the 3rd? What does that give me? 1. Okay, what if I have a fraction, 1 over 6, all of that to the 2nd power? What happens there?
Multiply the denominator.
Well, we can do two things. We can just multiply 1 over 6 times 1 over 6, right? Which would give me 1 over 36. Or we could also distribute that 2 into the parentheses, right? And that would give me 1 over 6 squared, which is 1 over 36. So you can do it one of two ways. You'll get the same answer either way. Okay, last one. I have 1/3 all of that to the -4th. So what should I do here? We can distribute it first, so that would be 1 to the -4 over 3 to the -4. And then what do I need to do? I flip them. That 1 comes down and that 3 goes up. So that gives me 3 to the 4th over 1 to the 4th, which is 81. So, for examples 2 and 3, now I want you, and this is very going back to kind of what we did on Friday before we, Friday after the final. We want to write 16 using a base 4. So I need to be able to break up 16 using a base 4. How could I do that? 4 and 4.
What's the base 4?
Base 4 means that that's the number being raised to the exponent. So how would I write 16 using a base 4? 4 to the 2nd power. So my base here is 4. Okay. Now, what if I want to write 16 using a base 2? 16 breaks up to 4 and 4, and 4 breaks down to 2 and 2. So that would be 2 to the 4th. So in this case, my base is 2. Okay? Okay. Now what we have is example multiple choice problems. These are very similar to what you might see on the STAR test. so we're going to go over it and kind of decide what the best way to approach these is. So, number 4. Given the expression x to the n, so we don't know what the base or the exponent are yet, where x is greater than 1 and n is greater than 1, which multiple choice statement is true? A, the value of x to the n equals 0. B, the value of x to the n is greater than 0. C, the value of x to the n is less than 0. Or D, the value of x to the n equals 1. What we can do here, because everything's a variable, is we can really just pick any variables we want and plug them into this expression, and it should give us kind of a reading of what our multiple choice answer is going to be. Now, because we're specifically limited to x is bigger than 1 and n's bigger than 1, I would suggest that we pick the closest number to 1 that we can get, so that we get the smallest possible answer. So that way we know everything is either bigger than the answer we get. Does that make sense? So what's the smallest possible number I could plug in for x? 2. What's the smallest possible number I could plug in for n?
2.
Also 2. Okay, so let's plug those into the expression. 2 to the second power gives me 4. Okay, so 4 is the smallest number I could possibly get when I plug it into x to the n, because I picked the 2 smallest possible numbers for x and n. So, which of these statements is true then? B. 4 is not equal to 0, 4 is not less than 0, and 4 is not equal to 1, so it has to be B. Okay, so, given the expression x to the n, same expression, where x is greater than 1. So what do we want to plug in for x? 2, because it's the closest thing we can get. And n is 0. So this time they actually give us a value of n. What multiple choice statement is true? Well, what's 2 to the 0? Always 1. So the answer is D. Okay, anything I plug in for x, because n has to equal 0, I will always get a 1. Okay. Okay, example 6. Given the equation y equals x to the n, where 0 is less than x and x is less than 1, and n is bigger than 1, what multiple choice statement is true? So now we need to pick an x that is in between 0 and 1. What do you think? 0.5. Let's do it. 1/2. I'm going to use a fraction though. Okay. So we're picking the number that's right in the middle of those two, 1/2. And n has to be bigger than 1, so what do you guys want to pick for n? How about 2? Okay, so let's plug those both in and see what we get. We get 1/2, that was our x, to the second power. What's 1/2 to the second power? 1/4. Okay, so is 1/4 equal to 0? No. Is 1/4 in between 0 and 1? Yeah. Is 1/4 less than 0? No. And is 1/4 equal to 1? No. So the only choice is B. Does this make sense, guys? You okay? Okay. Last one, number 7. Given the equation y equals x to the n, so same thing, where x is greater than 1 and n is less than 0, what multiple choice statement is true? What do you guys want to pick for x? 2. Okay, what do you want to pick for n? No, -1 is the next closest thing, but whenever I raise an exponent to 1, does it ever change the value? No, so let's pick the next smallest one so that we can work with it a little. -2. Let's pick -2. Okay, for exponents, or when we're picking these, we try to avoid 1 as much as possible, because 1 is a lot of times an exception to the rule. Okay, so we try not to pick 1. Okay, so what would that give me? That would give me 2 to the -2, which is...
When did you get the -2?
Okay, so 2 to the -2 is the same as 1 over 2 squared, which is 1 over 4. So what's my answer for this one? Also B. 1/4 is still not less than 0, so it's not C. And it's not equal to 0 or 1. So it's B.